Hello and welcome to MatMock.in. In this video, we are going to see a different types of sorting method, which is called as merge sort. Up till now, we have seen bubble sort, selection sort, and insertion sort. The link to all these sorting algorithms is given in the description. So you please go and watch all those types of sorting algorithms also. Merge sort works on the principle of divide and conquer. Divide and conquer strategy of algorithm says that you go and divide your problem into smallest sub problem so that until division or further division of your problem is not possible. So let us see how the dividing of your list works in a merge sort. Now suppose there is a list in which there are 8 different numbers and they are not arranged in a sequence. So in order to arrange them in a sequence, we divide the array into two parts, and further we divide array into four parts, and further we divide the array into 8 different parts. These 8 different parts have only one elements, so further division is not possible. See this, I am highlighting this part. In this part, further division is not possible because we have already got one single element in particular, one single element from the array. So further division is not possible. So what we have done here, we have divided the problem into smallest part so that there is no question of sorting. Imagine there is only one value in an array, like for example 6. So there is no question of comparing this 6 with any other number because in your list there is only one element. So in this way you go on dividing the array until further division is not possible. Now after dividing, what we do, we go on merge all these sub problems. While merging, you have to keep in mind that you are merging all these elements in ascending order. That means when we are merging 6 and 3, we do compare them and the smallest element will be added first and then followed by the largest element. Hence, the merging operation of 6 and 3 will be done as 3, 6. The same rule follows for following elements like 5 and 1. In case of 5 and 1, before merging these 5 and 1, we compare them and find that 1 is the smallest, so we keep it first, followed by 5. While comparing 8 and 2, we follow the same logic, hence the 2 will be first and 8 will be added later. In case of 4 and 7, 4 is already smallest as compared to 7, so we will add 4 first, followed by 7. Now we have to compare the array of two different. Now we have to merge the array of two elements into four elements. Like this 3, 6 element will be added into these 3 and 6 element will be added with 1 and 5 element. Now while adding these element, what we do, we compare the first element with the first element of second array. Like 1 will be compared with 3 and we find that 1 is the smallest, so we will add 1 here. After that we compare 5 with 3 and we find that 3 is the smallest, so 3 will be added here. Then we will compare 5 with 6 and we find that 5 is the smallest, so we add 5 here. And remaining all the elements, like for example here there is only one element, remaining all these elements will be copied into next location. Same logic will be followed while merging 2, 8 and 4, 7. First 2 will be copied, then 4 will be copied, and then 7 will be copied, and lastly 8 will be copied. So in this way we have got a list of 4 elements. In order to complete the merge sort, we have to compare all these elements and merge into the array. Like we will compare this 1 with 2 and we find that 1 is the smallest. Likewise 2 is the smallest among 2 and 3. Then we will compare 4 and 5, 3 and 4, and we find that 3 is the smallest, so 3 will be here. Then we will compare 5 and 4 and we find that 4 is the smallest, so 4 will be added here. Then we will compare 5 and 7, so 5 will be added here. Then we will compare 6 and 7, so 6 will be added here. So this array, left side array is exhausted now. When this array is exhausted, then all the elements, remaining elements of right array, that is 7 and 8, they will be copied into the new array as it is. Now the only thing remains is that the new array created will be copied into original array and you have got a sorted array. So in this way merge sort works. So let us see in stepwise manner how your divide of an array works. We have got an array of 8 elements. Here 0 indicates index number and 6 indicates the element. That means the upper line shows the index number and below line shows the elements. So index starts from 0 and it ends at 7. So that means total 8 elements are there because counting starts with 1 but indexing starts with 0. So how many elements are there? Total 8 elements are there. 1, 2, 3, 4, 5, 6, 7 and 8 elements are there. Now what we do? We follow here the formula of binary search to find the middle position, like mid is equal to low, that is 0, plus high, that is 7, divided by 2, right? So 7 divided by 2, in our case it is 3, right? So we 3, actually it is 3.5, but we don't consider the point value because our m variable is integer number, right? Because we want to reach some integer number, right? And that integer number is 3. So we have got the middle number. So what we will do? We will divide the array into two parts from index number 0, index number 1, index number 2 and index number 3. This will be one array, and index number 4, 5, 6 and 7. This will be another array, right? Here. So we have divided the array into two parts. Okay. Now what we do? We follow the same procedure to divide the array into two parts, right? So again we will calculate the middle of this. So to calculate the middle of this, again use the same formula. M is equal to 0 and what is the high? High is here 3, 0 plus 3 and divided by how much? Divided by 2, right? So 3 divided by 2 is how much? 3 divided by 2 is 1, right? So in this way we have got the middle position. So we will again divide the array into two parts, 0, 1, index number 0, 1 and index number 2, 3, right? For this part also we will do the same logic and we will recalculate the m. For recalculating the m, what will be the value of low here? The value of low will be 4, right? Because this is the lowest index and highest index is 7, right? So 4 plus 7. How much is 4 plus 7? 4 plus 7 is 11. 11 divided by 2 is how much? In round figure, it is 5, right? So 4, 5, this will be one array and 6 and 7 index number, this will be another array. So in this way we again divide this array into two parts, right? So we have got element with we have got an array with two elements, right? So likewise we further divide this array into single element and from there division is not possible because we have reached the our smallest sub problem. Smallest sub problem is the problem having only one element, because if you are having only one element then there is no question of sorting, it is already sorted, right? So in this way the right side array will also be divided, like so. This is the logic of dividing an array. So this is the this is the algorithm of merge sort. So in order to sort this merge, in order to write a C program for this merge sort, we have to use recursion. We have to use recursion. What is recursion? Recursion is nothing but calling a function itself, right? Calling a function calling itself is nothing but recursion. Okay, okay. So here the function name is merge sort and here two times this function is calling to itself, right? Why it is calling two times? Right, because see here in the previous slide you have seen that the array is divided into two parts. Okay, the array is divided into two parts. So you have divided this left part array as well as this right part array, right? This is the left part array and this is the right part array. So you have divided both the arrays, right? This is the right part, right? So you have divided both the arrays into two parts. Yes or no? Yes, we have divided this both the arrays into two parts. This array is further divided into two parts. This array is again divided into two parts. So this process of dividing goes on both sides, left and right. So that's why the algorithm says that you call merge sort for left part and you call merge sort for right part. Right? For merge sort for left part, lower bound, right? Lower bound is 0 and in your case the upper bound is 7, right? And when you calculate the mid, 0 plus 7 divided by 2 is how much? It is 3, right? From 0 to 3 you have got one array. From 0 to 3 you have got one array, and you from 4 to how much? From 4 to 7 you have got another array, right? And on both these array you have followed the procedure of dividing, right? So we will see in detail here. I will just keep this code for reference so that you will understand how this code will work. So I have taken an array of 7 element. The same array I have taken, which starts from index number 0 to and ends with index number 7, right? For this array we will hand run or dry run this code, right, to understand the concept of recursion working in merge sort. So what we will do, we will call this function merge sort. Initially the value of lower bound will be, what is your lower bound? It is 0. Here it is, right? And what is your upper bound? Upper bound is 7. So we give the value as 0 and 7 to merge sort, right? So in this merge sort, what we do? We have an if to compare the condition, right? Why this if is there? Because if this if is true, then and then only you are going to divide the array. If this if is false, then you are not going to divide the array, right? Why it is so? Let us see why it is so. Okay. So what we call a merge sort function with the value 0 and 7. We compare LB with UB. What is the value of LB? LB value is 0. What is the value of UB? UB value is 7. So 0 is less than 7. Yes, true. So come inside and calculate the mid. How much is mid? Mid is nothing but 3. Right. For this mid is nothing but 3. So what we do? We divide the merge sort. We call again merge sort. Right. So this function is not executed properly. It is not executed completely. And another function call has occur here. Right. With the value of LB 0, with the value of mid as 3, right? So this is how it is working. So for left part we call a merge sort with value 0 and 3, understanding? So when this merge sort is called, now execution of this merge sort will halt, right? And this merge sort will start its execution, right? When this call is starting, then again what is the value of LB? LB value is 0, and what is the value of UB? UB value is 3, right? So again compare, if 0 is less than 3, yes, come inside, calculate the mid. What is the value of mid? So 0 plus 3, 0 plus 3 divided by 2, how much? 0 plus 2 divided by 3 is nothing but 1. Okay, it is nothing but 1. So the mid value here is 1. Okay, so what we do? We calculate the mid value and we again call the left merge sort for this, right? So again one more function call is there. For this the value will be 0 comma mid. What is the new value of mid? New value of mid is 1. So merge sort 0 comma 1 will be called. Okay, 0 comma 1 will be called. Like then again this will call to left function which is 0 comma 0, right? Why this 0 comma 0? Because when it is 0 comma 1, at that time the mid value is 0. At that time the mid value is 0, and you are calling LB. LB is always 0 with mid. What is the new value of mid? The new value of mid is 0. Hence the 0 comma 0 function will call here, right? Again here what happens? Here the if condition is checked, LB less than UB. What is LB? LB here is 0, and what is UB? UB is also 0. If both are having the same value, if LB and UB are having both same value, at that time this if fails. This if fails, right? So if this if fails, then what happens? This function returns, it is not going to execute. After the returning of this function, what we got, right? What we got? We got the, here the mid value is 0, so I am writing 0. So after the completion of this function, what we got? we got the smallest element at 0 0. What is the smallest element at 0 0? 6, right? If you want to see, check here. The smallest element at index number 0, it is 6. Got it? After that, this merge sort complete, right? It will come back to this merge sort. This merge sort has called this line, right? This line has executed. After that, this line is remaining, no, right? This line is remaining. So what it will call? It will call a function merge sort with mid plus 1. How much is mid? Mid is 0. How much is 0 plus 1? It is 1. And how much is ub? Ub is your same, that is 1. Okay, ub is your 1, right? This is ub. So this again merge sort 1 comma 1. Here also the if fails, right? Here also the if fails. Now what happens? If the if is failing, it will give you only one element at index number 1, that is it will return 3, right? So for this function merge sort 0 comma 1, your left completed, right completed. Now only one function remains, that is merge. Now that only one function is remaining, that is merge. What this merge function does? This merge function will merge your 6 and 3. While merging, it will follow the rule that merging should happen in a ascending order, right? I will come back to the working of this function also. How this merge function works, I am going to cover that also. Please have a patience and let us see how this recursion works in merge sort, and then we will see in detail how this merge function works. Okay, so we have come to merge of this particular merge sort function, right? So while performing the merge, what should happen? It should give us 3 and 6, right? So it is given us 3 and 6. Here it is. First it has given 3 and then it has given us 6. Okay, so this function completes. So again come back to this function. This function has completed all its left part. Now this right part is remaining. Merge sort mid plus 1 comma ub. How much is mid plus 1? Mid is here 1. Okay, mid is here 1. How much is 1 plus 1? It is 2. And how much is ub? Ub is 3. So here it should be merge sort. What should be here? 1, sorry, 2 comma 3. Right, here you got 2 comma 3. Now its left should work first, right? And that left should be, what should be the left? 2 comma 2. Why 2 comma 2? Because when this merge sort is working, this if becomes true, it will calculate the mid value. 2 plus 3 is 5. 5 divided by 2 is how much? 5 divided by 2, how much? 3, right? 5 divided by 2 is 3, right? So again what happens here? 2 comma 5 divided by 2 is how much? Sorry, 5 divided by 2 is 2. 5 divided by 2 is 2, right? So here what happens? We got the 2 value here, right? So again it will call the this function LB. What is the value of LB? LB is 2 up to mid. What is new value of mid? That is 2. Hence it will call the 2 comma 2. So it's left also completed, because 2 comma 2, you know that if this if will be false and it will return only one value, that is 5, right? Then it will call what? 3 comma 3, right? Then it will call 3 comma 3 and it will give you only one value 1, right? So this merge sort 2 comma 3 has completed both the left and right dividation process, and only one function remains, that is merge. When we are merging 5 and 1, we will get 1 and 5, right? We will get 1 and 5. Okay, okay, we will get 1 and 5, right? So I hope you are understanding. Now for this merge sort 0 comma 3, what we have got? We have completed its left part as well as its right part, right? So this line executed, this line is also executed. Now we have come to execute up to this line. So when this line will execute, what will happen? It will merge these two arrays 3 comma 6 and 1 comma 5 into a single array. When we merge these two array, what we will get? We will get 1 3 5 and 6, right? Here we have got 1 3 5 and 6, right? So this function has completed its left part. Now the working of this function is remaining. Its left part is completed. Now its right part will be started, right? From this again the working of this function will started. Okay, I will clear it for better understanding. Okay. Now what is the mid of this function? How to calculate the mid of this function? By LB plus UB. How much LB plus UB is 0 plus 7 divided by 2. How much? It is 3. 3 is the mid value of this function. Okay. So you have completed this function. Now this you are going to work with mid plus 1. So how much is mid plus 1? That is 3 plus 1, 4. And how much is UB? UB is 7. Right. So here it will be merge sort. Here it will be merge sort 3 comma 7, right? Here it will be merge sort 3 comma 7. Okay, so let us see. Yes, sorry, 3 is the mid value, 4 comma 7, right? Here you got the 4 comma 7. When this merge sort is executing at the time, what happens? When this merge sort is executing at the time, what happens? It will again call its left part, right? This function will execute merge sort LB comma mid, right? For that purpose mid is calculated, and now the mid is how much? Mid is 5, right? Why 5? Because 4 plus 7, how much? 4 plus 7 is 11, and 11 divided by 2 is how much? In integer terms it is 5, right? So this is your LB and this is your mid, right? Because this function you are calling, no, LB comma mid, right? So again this function is working. This if loop, this if condition is true for this, again mid will be calculated, and again this will be called, right? The left, this merge sort function will be called. How it will be called? 4 comma 4, right? And 4 comma 4, what it will give you? It will give you the fourth index element, that is 8, right? And again 5 comma 5 will be called. It will give you index element 2. After that the merging will be done as 2 comma 8. Now it will, now this function will go to next line, and that is next line is merge sort mid plus, sorry, this function is already completed. This function will go to the next line, that is mid plus 1 comma UB. How much is mid? In this case the mid was 5, so 5 plus 1 is 6, so hence it is 6 comma 7, 6 comma 7, right? When this function is called, again it will call this line merge sort LB comma mid, and hence its left part will be called, that is 6 comma 6, and now 6 comma 6 will give you the sixth index element, that is 4, and 7 comma 7 will give you seventh index position, that is 7. 4 comma 7 will be merged into 4 7. Now this particular function, I will erase all these things so that it will be helpful to understand. Now this function has also completed its working. Only thing remaining is merge, right? This thing is remaining. When this line is executed, at the time what will happen? This 2 and 8 and 4 and 7 will be merged into a single array, single sorted array, that is 2 4 7 8. Now for this function merge sort 0 comma 7, all these lines, this left part is executed, this right part is executed, only the function remaining to execute is merge. When we perform this merge function on this array and this 2 4 7 8 array, then we got the final sorted array as 1 2 3 4 5 6 7 and 8. So in this way the merge sort recursion works. Okay, so please continue with the video, please stay here. Now we are going to see in detail the working of merging, right? Working of merging, right? In merge function, what we have given the arguments? We have given the argument as LB, mid and UB, right? For better understanding, I have taken the condition of last merging, right? In last merging, what we have done? We have merged 1 3 5 6 and 2 4 7 8. So let us see how these two array are merged into a single array, right? How to write a C program for this? So see here, 1 3 5 6 are there, right? This is index number 0, this is index number 1, this is index number 2, this is index number 3, likewise 4 5 6 and 7. Okay, so these are the index number. Now what I will do, I will take a I variable here, right? Then J variable here. Okay, then I will take a K variable here, right? These are my variables. Initially I is nothing but LB. What is LB? LB is nothing but your 0. What is mid plus 1? How much is mid? In this case mid is 3, right? In this case the mid is 3. You want to see whether the mid is 3 or not? Here 0 plus 7. How you calculated the mid? 0 plus 7 divided by 2. How much is 0 plus 7? 7. 7 divided by 2 is nothing but 3. Okay, 7 divided by 2 is nothing but 3. So mid is 3 here. So 3 plus 1, what I am doing here, the value of j is 3 plus 1. Why it is 3 plus 1? Because why it is 3 plus 1? See here, I will show you. I will first erase this, then I will show you why it is 3 plus 1. Okay, see here, j is equal to mid plus 1 is because j you point to this element 2, right? So what is the index number of this element 2? The index number of this element 2 is 4. Okay, the index number of this element 2 is 4. So what we require here? We require to go to the next element after mid element, right? So mid plus 1 is the next index number. No, 3 plus 1 is 4, right? So hence j is equal to mid plus 1. And what is k? K is nothing but your index number 0. This is a new array, that is the name of this array is b, right? And the name of your original array is a, right? These are the index number of in the array b, right? Why we are taking a new array? Because we are merging, right? For merging purpose we don't want to disturb the original array, right? So we create a new array, after that we copy the array, right? For copying it is very easy to copy the new array into the older array. Just write a for loop for I is equal to LB, LB value is 0, I less than UB, UB value is 7, right? Less than or equal to UB, and I plus plus. Just B of I is equal to A of I. This will copy all this new array B, all the element of new array B into the older array or initial array A to get the sorted elements, right? So without wasting the time, let us see what this while loop does, right? This while loop checks, what it checks, I is less than mid, I is less than or equal to mid. That means we are going to compare, all these elements, right? How much is this element? Index number 0, and up to what? Up to 3. 3 means what? Your mid. 3 means what? Mid. So we want to compare all these elements, hence I is less than or equal to mid condition is there. Also we want to compare all these elements, j is equal to mid plus 1 up to j is less than or equal to 7. 7 is nothing but your UB, upper bound, right? So hence there is UB, right? So until this exhaust, until j exhaust or I exhaust, we are going to follow this procedure. What is this procedure? This procedure is very simple procedure. Here just we are comparing a of I and a of j. That means we are comparing the value of 0th index of I and 4th index, that is j, right? What is a of I? A of I, the element is 1, and what is a of j? The element is 2. We are comparing 1 and 2, right? And then we are deciding whether 1 is going to stay here or 2 is going to copy here, right? So after deciding what we have decided, 1 should be copied here, right? The element 1 should be copied here. For that what we write? B of k is equal to a of I, right? Because this is I index, no, right? So B of k, this is B array, B of k is equal to a of I. And now what will happen? This I element should increment, right? Now this I element should increment, that is this I will point to this variable now, right? I incremented, yes, and k also incremented, yes, k also incremented, okay, k also incremented. Now what I will do, I will just erase these things, so for purpose of better understanding, right? Now I is pointing to this index number and k is pointing to this end. J is not moved. Why j is not moved? Because still we want to compare this 2 with 3, hence j is not incremented. Okay, what is incremented? The element which is already copied into B array, its index is incremented, otherwise it is not incremented. Now you will say that sir, you have incremented k. Where is k plus plus? Here it is. Now why this k plus plus is outside this if? Because if you are copying this I index value or j index value, anyway you are going to increase the k. Whether you are copying this I index value or j index value, it is going to copy into B. So k will be incremented in any case. That's why k plus plus is outside this if else. Okay, I hope you are understanding. Now what happens? Right, next time what happens when you compare 2 with 3? At that time what happens? You found that now j value is lesser, so it will go to the else part. Now b of k will be a of j, that is 2 will be copied here, right? When 2 will be copied here, at the time what happens? J got incremented. At the time what happens? J got incremented because j's value is copied, no, hence j got incremented, right? I remains as it is, and k also got incremented, right? Because k wants to copy all the elements, and hence k should point to the empty location, so k is also incremented, right? So this I am going to erase because k is incremented, right? And j is also incremented, hence I am also going to erase it, right? Getting? So this thing is going to happen until what? This thing is going to happen until your 4 and 3 will be compared. Now 3 will be copied, right? 3 will be copied here. Getting? And I will be incremented, right? I will be incremented. Likewise, k will be incremented here, right? K will be incremented, right? Shall I erase this? Yes, I can erase this I, because now I is pointing to new location, because I have copied the value of I, a of I into b of k, right? So j remains as it is. When we compare this 4 with 5, at that time what we find? We find that this j should be incremented, because j value is now I am going to copy it. First I will copy j value 4 here, right? And then I will increment the j, right? Then I will increment the j, then I will increment the k plus plus, and this is your position of I remains as it is, right? I remains as it is, right? I will erase this k. Now this is the position of your k variable and j variable. Okay, this is the position of I variable and j variable and k variable. Okay, now what should happen? Now 5 compare with 7. Which element should I copy? I should copy element 5 here. I should copy the element 5 here. Okay, now again this 5 is of which variable? I variable. So I should increment this I variable. Yes, I will increment this I variable, and I will also increment the k variable. Okay, how, where you have written the code? Sir, I am written the code here I plus plus, and here I have written k plus plus. Okay, so what will happen next time? Next time this 7 and 6 will compare, and 6 will be copied here. Now what happens? This while becomes false. Why this while becomes false? Because I is incremented by 1, right? After this copied, so I becomes 4, right? When I becomes 4, this condition I less than mid becomes false, and this while loop will terminate, and it will come to this line, right? Why this line, sir? This line I am writing because what I am doing here, I am going to see whether I part is exhausted or j part is exhausted. Exhausted means what? All the element from I part is already copied, or all the element of j part is already copied. So how logically I can come to conclusion all the elements of I part is completed? While I is less than or equal to mid. While I is less than or equal to mid. That means some of the elements are remaining in the I part, right? And while j is less than or equal to ub, that means some elements are remaining in the j part. Now in our case, j is less than or equal to ub, because j's latest value is 6, and hence it is less than 7, right? So what we have to do? We have to copy all the elements of j part into this b variable, right? So what we do? B of k is equal to a of j, and we increment j plus plus, and we also increment k plus plus, and this 7 will be copied here. Again this will check j is less than or equal to ub. Yes, now j is pointing to this, j is equal to 7, and hence we have to also copy the 8 here. And then j plus plus, now j is not less than or equal to ub, this condition false. I is also not less than or equal to mid, this condition is also false, and this for loop will execute to copy all the elements of your what? Of your b array into this a array, right? So in this way the merging of small elements into a larger array is done. While merging, we have checked whether the element is smaller or not, and if it is so, then only we have copied, otherwise we have stayed there until we found the smallest element, right? So this is the simple logic of merge sort. I hope you all are understanding. So if you are not understanding all the concept, please write in the comments. Please do subscribe to our channel. Please share this video if you have liked it. Thank you very much.